Welcome back to the deep dive. Today we are jumping into some highly specialized video gear.
We really are.
We're focusing on a very specific problem.
Yeah.
How do you send high-res video over, just massive distances without the signal completely falling apart?
Exactly. And for our source material, we're looking at the DVIGear DVI-7311. It's a single-link DVI fiber optic extender.
Okay.
So, the core idea here is it's a system, a transmitter, and a receiver that turns DVI signals into pulses of light. It's not about new standards. It's about pushing an older one, BVI, to its absolute limit.
So our mission today is to get a quick handle on the benefits and maybe more importantly, the compromises this kind of system has to make.
Well, let's start with the big headliner, distance.
Right.
This thing supports cable lengths up to 500 meters.
Wow. 500 meters. That's, what, over 1,600 feet?
It's a huge distance, half a kilometer. That right there tells you what the #1 priority is.
And to do that, you need some serious cabling. I see it requires 4 separate strands of 50125 micron LC multi-mode fiber. So what's the big win that justifies running that much specific fiber?
Signal purity. That's the whole game. The main advantage of using optical fiber is that it's just completely immune to environmental signal noise.
Okay, so like electrical interference.
Exactly. It has a very low RFEME profile. So, radio frequency, electromagnetic interference.
Sure.
Think about places like hospitals or military ops centers, even industrial facilities.
Places where standard copper cabling will just get swamped with noise and fail.
It would be unusable. Here, the signal just clean light.
And you're not sacrificing quality over that half kilometer. It's still supporting HDTV resolutions up to 1080p and PC resolutions up to 1920 by 1200.
Correct. You're holding a max bit rate of 1.65 gigabits per second. That 165 megahertz pixel clock is stable across the entire run. The integrity is, well, it's basically flawless.
That's incredible.
And moving into some of the more technical details, there's a really convenient feature built right into the transmitter.
Oh, yeah.
It's user-programmable EDAG memory.
Ah, EDAD. So that's how the computer knows what the monitor can handle.
Exactly. And by building it into the transmitter module, you completely eliminate the need for the DDC connection, the data display channel.
Which usually needs its own copy wires in the cable.
Right. So this makes the whole setup cleaner. No need for that extra copper link.
Okay, that makes sense. But we do need to talk about the crucial limitations. I'm looking at the specs, and the DVI-7311 does not support HDCP.
Correct.
And no digital audio either. Wait, no HDCP? That's the copy protection for, Blu-rays, streaming.
Yep. High bandwidth digital content protection. It's not there.
So what's the niche here? Who can actually use a device that ignores that standard?
And that's the core trade-off. That tells you who this is for. It's designed for professional, industrial, or government applications, places where the content is generated internally.
Like surveillance feeds.
Surveillance feeds, control screens, complex simulation data. Content where copyright is not even a factor. By stripping out that HDCP handshake complexity, they ensure maximum reliability for the video signal itself.
That context is everything. Okay, and physically, these things are tiny.
Oh yeah, they're small. About 2.5 by 1.7 inches, weigh just an ounce.
But there's a detail on power to watch out for. The transmitter, the TX, can draw power from the DVI source itself.
Right, about 320 milliamps from pin 14. Or you can use an external supply.
But the receiver, the RX, must have its own external power supply.
It has to, yeah. That's a key installation detail.
So wrapping this up, the high-value takeaway seems to be that this is a laser-focused tool. It's a problem solver.
That's a perfect way to put it. It solves the dual problem of extreme distance and noise. It unapologetically picks signal fidelity and reach over, modern consumer features.
Which leaves a final question for you to mull over. In a world where everything is moving towards features like HDCP, what kind of critical application, maybe industrial or military, would require this